I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for identifying linear functions. First of all, a linear function is a function whose graph forms a straight line because it has a constant rate of change. So we already studied functions. Now we're looking at specific type of function, which is linear. Linear, you'll notice the root word there is line. So a linear function is a straight line. So example A is a linear function because it is a straight line. Example B is not a linear function because it is not a straight line. When you're looking at a table, in order to determine if it is linear or not, we need to determine the rate of change. As I mentioned, a linear function has a constant rate of change, which means the rate of change does not differ between points. The rate of change is the ratio between the y and the x. So on the y column, this is going down by 3, this is going down by 3, down by 3, down by 3. In the x column, this is going up 1, up 1, up 1, up 1. So the rate of change is -3 over 1, and that stays constant throughout the data. So because it's always -3 over 1, this is a linear function. If we look at example B, again, we want to determine the difference in the y and the difference in the x, and we're going to see if the rate of change stays constant. So the difference in the y is -3, then it's -1, then it's +1, and then it's +3. If we look at the change in x, this is +1, +1, +1, +1. So I notice that my rate of change is -3 over 1, but in the next space, it's -1 over 1, and those are not equal, so this is not linear. In our last example, the rate of change in the change in y is -1, then it's -2, and then it's -1 again, and my x is +3, +6, and +3 again. So the change in y in the first 2 points is -1 over the change in x is 3. And then in the next points, it's -2 over 6. Well, if I simplify -2 over 6, then that is equal to -1/3. So this is equal, which means this is linear. So please be very careful. Just because you see that the y's are changing by a different amount, that doesn't mean that the rate of change is not the same, because the x's may also be changing by a different amount. Standard form of a linear equation is ax plus by equals c. A, b, and c are real numbers. And then x and y, those are our variables, our independent and our dependent variable. So how do we know if it's linear from an equation? Well, it needs to somehow be able to be written like this. If we can't rewrite it in that form, then it's not linear. So if you look at example A, y equals 4x minus 2. Could I make it look like standard form? Well, if I subtract 4x on both sides, then I get -4x plus y equals -2, which looks like ax plus by equals c, so that is linear. In my second example, 3x squared, hold on, that's a problem. I don't have an x squared in my standard form, so this is not linear. The variables cannot have an exponent. Example C, 6x minus 2y equals 1. Well, that looks like it's already in standard form. Now, maybe you're saying, well, but this is a -2, not a plus. Well, that just means that B would be -2, which is fine. So it doesn't have to have a plus there if the B is negative. So that is linear. And then lastly, 3 over x plus y equals 5. That's a problem. This x in the denominator means that it's not linear. So that's how you determine if a function is linear from a graph, tables, and an equation.
I've been waiting way too long. Yeah.